So in the video, you saw that the sun is constantly creating these explosions. I mean, imagine if every single country on this planet exploded their nuclear bombs, it wouldn't even come close to what's happening every second on the sun. And it's exploding, so you have this push outwards of all this energy. But because it's so massive, you also have this pull inwards of gravity. So that's why you get the sun in this ball form, because it's trying to go outwards but also pull inwards at the same time. That's what creates all this massive amount of pressure. There's so much pressure in the middle core of the sun that if you took coal, well, coal would vaporize before you got there, but if you took coal and it didn't vaporize, that pressure and heat would create diamonds almost instantly, because that's how diamonds are created. They get there's pressure and heat through the earth processes turning coal into diamonds. Diamonds would be formed almost instantly on the sun because there's so much pressure and heat. Now, the stars have different temperatures, right? So the middle of the star, the core, is almost some of the hottest parts of the star. Now, there are some recorded temperatures in the photosphere, the atmosphere of the star, that have reached temperatures above that. So there could be temperatures in that outer atmosphere that are even hotter than the core, which is pretty amazing. But the temperatures range from about 5 million Kelvin to about 100 million Kelvin. That's hot. That's hot.
Dear Tim and Moby, why is the sun so hot? It's actually a star. The closest one to Earth. It's so small. It's about 150 million kilometers away, but it's actually a million times the size of Earth. Even so, you still feel its immense heat. Well, the sun is way hotter than a stove. The photosphere, or surface of the sun, is close to 6,000 degrees Celsius. If you went down into the core of the sun, you'd experience temperatures around 14 million degrees Celsius. Right, don't go into the sun. The sun is made of mostly hydrogen and helium. Nuclear fusion reactions caused by the sun's massive gravitational field use the sun's hydrogen to heat. This produces enormous amounts of energy, way more than enough to power all life on Earth. Energy from the sun makes plants grow, the general eat, or in turn, eaten by other animals. The tilt of the Earth causes sunlight to strike at a different angle throughout the year, causing seasons. The sun dictates the seasons, controls the weather, and drives the water cycle. Take away the sun, and the Earth would quickly become a frozen ball of lifeless rock. We're also lucky that the Earth is just the right distance from the sun. A little closer, and all of our life-sustaining water would boil away into space. A little further, it would all freeze solid. The sun was created out of the same cloud of gas and dust that formed the rest of the solar system. The cloud probably came from an old star that exploded at the end of its life, as stars sometimes do. Today, the sun contains 99.8% of the mass of the solar system. That's almost everything. In case you were wondering, the sun is middle-aged. It's about 4.5 billion years old, and it's got another 4 to 5 billion years to go. At the end of its life, the sun will expand into a red giant, reaching out all the way to where Earth is, but then throwing off its outer layers of a planetary nebula. Well, these days, the sun is a very active place. Enormous jets of burning gas called prominences and strange dark patches of sunspots are caused by the sun's gigantic electromagnetic field. Sunspots, as well as other solar activity, seem to follow an 11-year cycle. The sun's atmosphere, or corona, can be seen during an eclipse. Which reminds me, don't ever look directly at the sun. Powerful solar radiation can blind you for good, and no one wants that. Likewise, be sure to sunblock when you're outside for long periods. Ultraviolet radiation from the sun can cause permanent damage to your skin. So respect the sun. Love the sun. You don't have to take care of the sun.
Now, I want you to be aware that the sun has affected a lot of our human lives in the past and right now. One of the big ones is the sun's radiation. The part of the sun that hits you that you feel is the part of the sun that you don't see. It's below, it's infrared, meaning below the red spectrum. We don't see it. But that's where we get a lot of the damage caused to our skin. That's where skin cancer and all that solar radiation comes from. Now, our bodies are very good at adapting to that. We have a chemical in our cells known as melanin. Melanin is what makes our cells a little bit darker as we go across. So when you are suntanning, it's your body reacting, saying, hey, we're getting too much of this radiation. We need to fix something. So this melanin pigment goes over the nucleus to prevent the nucleus from getting messed up. Right? That's what cancer is. It changes the cell's nucleus and makes it replicate itself, and it's bad. So you get this melanin that comes over, so it helps you out. Historically, those whose ancestors lived in a place where they get lots of sun, okay? I'm talking about like South America or Africa. You have darker skinned individuals because their ancestors lived in that place and they had to adapt with a darker skin to protect their cells from mutating because of that. Skin color is a direct adaptation to the sun's rays. It has nothing to do with anything else. People that come from the Anglo-Saxon line of people coming from England, they are very well known to have overcast, meaning a blocking of the sun due to lots of clouds, very, very overcast type weather. And so they're going to have lighter skin. So people that are descended from Europeans are going to have lighter skin than those who are descended from Africans. Skin color only has to do with the way your ancestors adapted to help them prevent their cells from killing them. That's all skin color is. So it always makes me very upset when you hear people talk about, especially in the past, saying skin color has to do with intelligence and stuff like that. Absolutely dumb. That is the stupidest idea I've ever heard. Skin color is only there to help you stay alive based upon where your ancestors lived. That is it. Now understand, it's only until recently that humans have been allowed to travel out from where they were born. About 300, 400 years ago, if you were born one place, you stayed there. You hardly ever left that little tiny 5-mile radius of what you called home. Now we get to travel everywhere. We get to see people all over the place. So you're going to start seeing, as the years get longer and longer, skin colors will start changing again. Okay? But that's all skin color is. It's from your descendants, from where your ancestors lived and survived. That's what skin color is. It has nothing to do with anything else. So this whole idea of racism that I hear all around the world, and you see it in the media right now with that guy from Nevada, right? That crazy old guy, or that owner of the Clippers. Horrendous ridiculousness when it comes to racism, right? It's horrible. If you just understand that skin color only has to do with us protecting ourselves from the sun, it puts everything into perspective. So just keep that in mind when you start going through life and you hear people talk about other people based upon their race. Just look at them and go, dude, it's just about the sun, right? Get a clue. That's all it has to do with. So sorry about my rant. But with all this stuff in the media about these people's ideas, it's just, it's ridiculous. Now, how do we know what's in a star? Right? We can't go up to the star and take a scoop and go, I'm going to test this. For number one, your scoop would melt. And number two, you'd be dead. So we can't do that. So we have to do something, taking a look at the spectrum. And here's the amazing thing about how we discovered how to do this. It was all discovered by women. And I say this is amazing, not because women can't do this work. In fact, they can, and it's been proven through this. But because in the past, women were not allowed to get a higher education. Right? That's one way that societies kept women down, was by not allowing them to go to school or to get a higher education than men. Simple fact. So in Stanford in the early 1900s, you had this scientist that had a group of women working for him on figuring out what stars were made of. And these women are the one that came up with the classification of stars. They were in a room and they all worked together, and he called them his computers. Not computers like technology computers. Those weren't around back then. But people that did computations for him. And they actually ended up figuring out what stars are made of, how big they are, how far away they are, how do we classify them. Okay, these women did all this work. And when the guy published his findings, guess whose name was on top? The guy's name. And the women's names were either very tiny or not even there. It's not only until recently we find out how big of an impact these ladies had on astronomy. And then there was another lady that heard about these women, and she lived in England. And in England at this time, you were not allowed to get a higher education. So she immigrated to the United States, applied at Stanford, got into the master's program, and worked with these women. And she is the one that discovered what stars are truly made of. The men at the time thought that the stars were made of everything that the earth was made of. They felt that it had an iron core, and it just so happened that the core combusted, creating this. And she said, no. Look, if you look at the spectrum, it tells us what it's made of. Those lines, see those lines in that rainbow look? That's like a barcode, right? A barcode is something at a restaurant or at a store. You scan it, it tells you what you have. If you were to scan that first one, it's hydrogen. Everything that has hydrogen has that barcode. Everything that has helium has that barcode. And she discovered this, and she wrote her thesis on it. And understand, a thesis is like a paper, but like 500 pages long. And she wrote her thesis on it to get her PhD. And she turned it in to the head of the astronomy department at Stanford, and he laughed at her. He wrote her a note saying, you don't know what you're doing. You have no idea what you're talking about. This is complete rubbish. And she believed him. She's like, oh, maybe I am off the track. Maybe I'm not doing it right. And this guy, 4 years later, goes, oh, wait, she was right. But luckily, instead of claiming he discovered it, he gave her full credit. Okay? So women have been in science for a long time, doing a lot of stuff, and now we know how far away stars are, how big they are, what color they are, and what makes them up, all due to this contribution of women in the early 1900s. Okay? Pretty amazing fact, because a lot of people don't think women did anything. They did. When they were given a chance, they proved that this whole gender thing was not real. Okay, once again, people thought if you were a woman, you were not as smart as men, so you shouldn't have jobs like men. And we're still fighting that today, right? Pretty ridiculous when you look into the news, seeing how much a man makes compared to what a woman makes in the exact same job. It's stupid, right? It's dumb. Sorry. And so we figured out that a red star is the coolest star. Now that's kind of weird, because in your brain, ever since kindergarten, you've been told red means hot and blue means cold. So in your kindergarten brain, you're going to get this wrong. Because when I ask you what is the hottest star, you're going to go, oh, red means hot and blue means cold, so red. But that's not the case with stars. Think about fire. When you are at a campfire, you always say, ooh, look, the blue flame's the hottest. Yeah, just like in a star. The blue flame is the hottest. The red flame is the coolest. So in a star, red is cool, yellow is medium, white is hot. That's why they say white hot. And blue is extremely hot. Those are the different types of stars. And the funny thing is, their sizes are big star, low temperature. Little star, high temperature. Because red giants, red stars, are the biggest, but they're the coolest. White and blue stars are the smallest. So just keep that in mind. Now, star size. When it comes to us, our star is average. It's not the biggest, it's not the smallest. It's not the hottest, it's not the coolest. It's the mediumest, right? It's about the middle size of a star and the middle heat of a star. There's nothing real special about it. In fact, it fits on this thing that we call the main sequence. And it's this thing that this guy created called the HR diagram, and you have like kind of like a graph, and it tells you where all the stars should fall. And ours is right smack in the middle of that main sequence. So we're a main sequence star, right smack in the middle. But compared to other stars, there's enormous stars out there. Now I want you to keep this in mind. Our star creates enough gravity to hold 8 planets. 9 if you count Pluto because you're still upset about that, right? But 8 planets. A larger star can hold way more, and we know that for a fact because the inner 4 planets are tiny compared to the outer 4 planets, which are gigantic. And the inner 4 planets have about 1 to 2 moons that surround it. The outer planets have upwards of 63 moons that surround them. So just imagine how many planets a ginormous star can hold. Now, does planet size have anything to do with star size? Are our planets tiny because our sun is medium? What if it's a gigantic star? Would their planets be even more gigantic? And then are organisms defined by their planet, right? Are we only as big as our planet can produce? If there's a bigger planet, can they produce bigger organisms? I know for a fact that other planets can produce stronger organisms. Other planets can produce weaker organisms based upon gravity. Our bodies are perfectly adapted for Earth, right? I mean, think about it. When you're born, can babies instantly come out and walk? No, their muscles are not used to it yet. But as they grow up, their muscles acclimate. That means they get used to the environment that they're in. They're used to the gravity that we're in, and they get strong enough to walk. So their muscles are strong enough to walk in Earth's gravity. Now, we do have some individuals that try to push Earth's gravity by weightlifting. And all it is increasing gravity and making them go up. And what happens when you increase gravity in weightlifters? Their muscles get bigger. Now, what if you live on a planet where the gravity is just enormous, just by itself? Your muscles are just going to get enormous just by themselves. You don't even have to work out. Just to survive on that big planet, you have to get big muscles. So just imagine aliens coming from a planet that has a gravity 5 times ours. They're going to be big. And if they can jump like normal on their planet, they'll jump 5 times higher on our planet. If they can lift normal on their planet, they can lift 5 times as much on our planet. See where I'm getting here? Superman is possible. Right? If you got an alien from a planet with enormous gravity and they come to a planet like ours, which has less gravity, they are going to have superhuman powers just because they come from a larger planet. Now, the X-ray vision and all that stuff, I have no idea. And in fact, what about flying? Well, the original Superman had no flying powers. Right? He could leap tall buildings in a single bound. He had nothing to do with flying. Only later on did they add the flying aspect to Superman. But the actual idea of a Superman is plausible. Speaking of the Mythbusters terminology, it's plausible because there are larger planets which produce organisms that have to live on those planets. But I want to show you really quick our perspective. Now, it's going to show you sizes of our inner planets, then our larger planets, then our star, called the sun, and then we're going to compare our star, the sun, to the other stars that we have discovered. I want you to try to keep your eye on our star. Try not to lose perspective of it. Okay? Whoops, that's not it. That's not it. This is it. Okay, there's Mercury, there's Mars. This is in order of size. Venus and Earth about the same size. There's Neptune, Saturn, Jupiter. Uranus is about the same size as Neptune. I don't know why they skipped it. Now look at our sun. Now keep an eye on the sun. These are all stars in the sky and their relative size. Keep an eye on our sun. And then imagine how small we are. Kind of puts things into perspective, right? I mean, we're tiny, right? 1,000,000 Earths can fit into our sun. 7 billion people live on our planet, and we're not even halfway full. Just imagine how tiny we are when you put everything into perspective. Right? We always think everything revolves around us, that we're the greatest thing ever. We're infinitesimal when you talk about the entire universe. Right? So it's just amazing that we can do everything that we can do on our planet in our societies. It just makes everything that humans have done that much more amazing, considering how tiny we are compared to everything else. Right? All the stupid wars and arguments and debates and all these things that we as a human society have conflict with each other, completely wiped out by our infinitesimally small aspect compared to the entire universe. Okay, crazy when you think about it. Ronald Reagan said this, right? Ronald Reagan said this. Ronald Reagan said, just imagine how our perspective of our societies would change if we encountered alien life. He said that because it means that we're not individuals on a planet that don't have an outer community. It would make the human race even more connected to each other to know that there's something else out there that is not connected to us. That's what Ronald Reagan said, and I think it's kind of true. Okay, now a lot of people think he said that he believed in aliens. I don't think he believed that, but he's saying all the little wars and squabbles and human-created conflicts that we have on this planet would go away when we realize there's other stuff out there, and we should really combine our efforts to work together. I don't know why it would take something that big for us to do that, but apparently it does, because when you see the perspective of us compared to everything else, it's kind of silly to think that we as humans fight with each other over stupid little things that we create. It's dumb. Okay? When you see that video, it just blows your mind. It blows my mind every time I see it, because I think the sun is enormous. Then I see the My Cepheids, and I'm like, whoa, that's ridiculous. Okay? It's a game changer for me when I see these things. Hopefully it starts to be a game changer for you. Amazingly enough, you're young enough to take that and run with it in any way that you want in the future. Okay, pretty crazy. Okay, so we're going to stop there. Any questions on any of these questions? Okay, good. Let me stop the recording.